Hello. So in this video, we will be talking about a very important concept in BIM called object-oriented modeling. This video corresponds to our learning objective in explaining object-oriented modeling in BIM. In our last lecture, we talked about the three characteristics of BIM, one being the object-oriented modeling, one being parametric modeling for geometry and constraints, and the other one is the central database that supports multiple views. So this slide set up the context for this video, talking about object-oriented modeling. So the first characteristic, right? Object-oriented modeling. We said in BIM, everything is viewed as an object. So this becomes very natural that we would like to take an object-oriented modeling approach to model everything as an object. Here we define object-oriented modeling as a modeling process in which everything is represented as an object. Every object has a unique ID to distinguish it from other objects, has a set of properties or attributes to describe the object from multiple aspects, and behavior functions that refer to things that the object can do or can function. Objects of the same type are grouped and abstracted together into a class. Let's take a look at an example, right? In our engineering products, such as buildings, bridges, roads, and highways, they have a very high representational complexity. Thinking about a building is composed of many objects. Now let's look at these two buildings. They are the same building, but one displaying the building envelope, while the other one shows all the structural elements. Now let's take a look at these and tell me how many objects do you see and what are they? Okay, I'm hoping you actually come up with at least the same amount of objects that I have illustrated on this slide. If you look at the architectural model or look at the building envelope to the left side, you shall be able to notice the roof, the windows, the wall itself, and the doors. And probably some of you also noticed that at the bottom, the wall is showing a different color. So that's a separate or a different type of wall, or sometimes we call that the foundational walls. Now to the right, it's the structural element. You shall be able to tell we have beams, we have elevation wall, we have truss, we have slabs, we have stairs, concrete columns, footing, foundation wall, and a steel column. So as you can see, we have a lot of objects or a lot of components in a single building. Apparently, this list is not complete. Many of the elements that we are not showing here, they all become part of the building. So for example, you will have lights, right? These lights are also part of your building components. So you end up with seeing thousands, if not more lights in a big building. So let's take an exercise, right? Let's take an exercise. We said everything is an object, and an object has a unique ID, has a set of properties and attributes, and also a set of behavior or functions. Now take a look at this example. We would like to ask you to examine the wall highlighted in the yellow or the orange box. This is a typical interior wall in a classroom setting. Now what I would like you to do is to write down your description of the wall, identify the ID, list their attributes, properties, and the functional behavior information if you can think of anything. It is a good time to pause and work on the exercise. So I suggest that you pause and make your hands busy and work on this exercise. Spend 3 minutes on this one and then move on to the next slide. I assume you had some good exercise. So here's the information items that I came up with, as well as the behavior and the functions I would like to use to describe this object, this wall. So the ID, my mysterious wall, I give it an ID of 001. And the set of attributes include the depth, location, base constraint, top constraint, color, material, type, dimensions, and the list can go on. Your list might be different than mine, but that's okay, because we have many aspects to describe a single wall, and not everything single aspect should have a value here. Now, regarding behavior or function, we say this is an interior wall, so one of its main functionality is to separate the space, right? Separate the space, separate the classroom from the hallway. Or the other part to look at this one is actually a functionality that encloses the classroom. It is also a wall. Because it is a wall, you end up seeing a door on top on it, right? So this wall functions as a host for a door. It can also host a whiteboard. It self-occupies space. If even it's an interior wall, we don't expect that to be a load-bearing wall, but it still can bear some light loads, right? Bear some loads. So when we took a graphical illustration, all these information items can be represented in a 3-compartment format, as the one being shown on the right side. On the top, the very first compartment, let me change my color. Let me change my pointer type here. So the top compartment, that's my ID compartment. This is the place that I put my ID there. And the second compartment, the second box right here, lists all the attributes and their values. So for example, width is an attribute or property, and its value is 14 feet 6 inch, right? And the third compartment is at the bottom right here. This is the compartment where I put all my functions or behaviors in it. And this shows they are all represented as functions. So now let's carry it a little bit further, right? We can have many walls in a building. So let's say we have 2 walls, 250460. That's one wall with an ID, and another wall with an ID of 250470. So these two values are different, and they help to uniquely identify each object. But if you look at the wall attributes, right? Look at the attributes, and also look at the list of functions. What are your observations? Apparently, you're going to be telling me their values change, but the set of attributes remain the same, right? The set of attributes remain the same. And also the list of functions remain the same as well. So in other words, you can have as many objects as you want to. They all have the same list of attributes and the functions, although their values are different, right? And their IDs are different. So if we group all these same objects together, same type of objects together, and extract the common set of attributes and the functions out, we call that a class. A class. So this class has a name called a wall, right? Because we are using this wall class to represent all the wall objects. And at the class level, we still list all the attributes and also list all the functions. But we don't give these attributes any values, because you won't be able to have a single value for all objects under that class, right? Under that class. And the same thing, we have also the list of functions, but the actual implementation or how these objects behave are left into the details of the object. So this is a process called abstraction. You take all the same type of objects, you extract all the common set of attributes and the functions, and you abstract them into a class. Now, the process can be reversed, which means now if you have a class designed, let's say you have a wall class, and it gives you a list of attributes and their behavioral functions, you can use this design to create as many objects as you want to. So the whole process of taking a class design and then create many objects is the process we call that instantiation, right? Instantiation. So again, taking objects and grouping them into a single class, this is the process called abstraction. And when you take a class design and create many objects based on this design, this is called instantiation. This is called instantiation. Now let's take a look at the everyday life example again. Look at the bicycles, right? Look at them. Thinking about bicycle design and production. We can use one design for a group of bicycles and the same assembly for a specific model, no matter how many bicycles we produce, right? How many bicycles we produce. So this leads to the concept right here. We have many bicycles, right? We have many bicycles. But if you look at many bicycles, I mean, they can all be described by the same set of attributes. What is the frame size? What is the wheel size? What are the gears? What is the material, right? And you can use different frame size. You can use you have different wheel size. You can use different gears. You can use different materials. But they are all part of this class called bicycle. And every individual bicycle becomes a bicycle object. So this same concept applies to car production, I mean in car design and production, right? We use one design for a group of cars and the same assembly line for a specific model, no matter how many cars we would like to produce. So just to do a recap before we move on, everything in BIM is an object, and we use object-oriented modeling to complete the modeling process in BIM. In object-oriented modeling, every object is described by a unique ID, a set of properties and attributes, and a set of functions or behavior. The same type of objects are grouped together. Their common list of attributes and behaviors got extracted and put into a class, right? Into a class. This is a process called abstraction. And then you can take the class and create as many objects as you want to. And this process is called instantiation. So by taking objects, class, instantiation, and abstraction together, they form a complete cycle or a loop. Exercise 1. So this is the exercise I would like you to work on. Look around your own location. Identify and count the windows, and follow the abstraction process to design an object-oriented model for your windows. With this one, I would like to conclude today's lecture.